Carbon dioxide is an important heat-trapping gas, which is released through human activities such as deforestation and burning fossil fuels, as well as natural processes such as respiration and volcanic eruptions. Atmospheric CO2, temperature and sea level are interconnected and produce cycles in the Earth's climate. Historic climate cycles can be used to predict how current CO2 levels will impact oceans. Over the last 800,000 years, the Earth has cycled between glacial and interglacial periods. Changes in temperature occur alongside changes in sea level. Over a cycle, sea level varies by around 120 metres due to the growth and melt of ice sheets. All of this is caused by variations in atmospheric CO2 concentrations. Previous climate cycles fluctuate between 180 and 300 parts per million of CO2. However, the present-day atmospheric concentrations are over 400 ppm of CO2, much higher than any previous climate cycle. But what drives natural climate cycles? If we imagine the journey of a single CO2 molecule, 21,000 years ago, during the last glacial maximum, atmospheric CO2 levels were around 180 ppm, our CO2 molecule being one of them. Since then, atmospheric CO2 levels have increased. Global temperature has risen, land ice melted, with meltwater running into the seas, causing sea levels to rise. This covered some exposed lands, creating shallow seas, or shelf seas. As shelf seas and the atmosphere are constantly trying to reach equilibrium with regards to CO2, our CO2 molecule is drawn into the sea. Shelf seas help sequester carbon into deep oceans via the continental shelf pump. NERC researchers are working to fully understand how vital shelf seas are to the global carbon cycle. Their findings can be used to improve computer model predictions to make assessments of future climate change even more accurate and reliable.